Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's LYNDA.com/C101. Today on Coding 101, we're continuing our C module and we're wading into pointers. Hello and welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey and the Code Warrior. I'm Father Robert Ballecer, the digital Jesuit, and I'm joined by my super special guest co-host / Code Warrior. We really got to work on that title. Mr. Lou Maresca. Lou, welcome back to Coding 101.
Hey, thanks for having me again. I'm excited.
Now, of course, we are pre-recording this show because I'm at NAB right now. We don't normally say that we're pre-recording, but I'm going to do it now because I want to be honest with the audience. We were supposed to do this a couple hours earlier, but you had an interesting afternoon stuck on a freeway somewhere?
Car trouble, yeah. I was changing a tire during rush hour. It was fun.
Well, I hear that this is what happens when you drive back from Microsoft. You just, you lose a tire.
Get flat tires.
You get a flat tire. Actually, the story that I want to talk a little bit about does concern Microsoft because I was in a forum the other night and people were talking about how the rise of containerized services is changing the way that people program. And I didn't think about this, but this is absolutely true. When we used to think about programming teams, you would typically build up some sort of application suite, a development suite that you could hang things off of. But, we've gotten a lot of announcements from Microsoft this last week about their Nano server. It's going to come in Server 2016. And the idea is they're breaking it down into just the bare bones. And then you hang off microservices on it. It's called Nano server so that you can containerize them and then just spin up the instances as you need them. What does that do to the programmer? Because you can't think the same way, right?
I mean, if you think about it, it's basically taking virtualization to the next level because when you're building an application, you basically are building it in this like a sandbox, basically, and it's allowing you to then virtualize it and have multiple different sandboxes on the same server. So same machine. So when you're actually building your application, you might actually be running right next to the same instance of that application on the same machine. And so you kind of have to think about, you have to be more careful with what you're doing, how much resources you're taking, and are you taking too much CPU, or are you taking too much memory, that kind of thing. So it changes kind of the way the programmer has to think when they're building their application. Right.
I mean, if you look at the announcement that Microsoft made about this Nano server, it's going to be 1/20th the size of the Windows Server core. It's going to only have things like Hyper-V, clustering, networking, storage, .NET Core, CLR, and no GUI. So, I mean, they really have stripped this thing down, which historically is something that Microsoft has avoided doing. And they've done it for Windows XP Embedded. They've done it for a couple of .NET projects, but they don't like making people or letting people have just the core components. That's not been a core philosophy for Microsoft. So, of course, that's changed. And as you said, now that the shift has been to containerization, where you can have a lot of instances of the same services to handle the load rather than one really big, powerful framework. I guess, like, for example, I can't be always calling out for resources, right? I mean, how do I do that?
Yeah, so I mean, if you think about it, like Microsoft Windows has had the capability for you to just do a GUI for a while, or no GUI for a while, so you could do just a command prompt. But like you said, it has all these other things already installed on it. There's lots of different packages, PowerShell, all those things are still there when you have just the command prompt version of Windows. But now they're, like you said, now they're breaking it down to kind of almost like a Unix style, where it's, like you said, containerized. And now when you're talking about resources, when you boot this thing up, it takes very little resources. almost no CPU, and then you have the chance to build an application, whether it be a service or just a standalone application, that allows you to utilize, almost 100% of the resources, because now you're breaking it up into these little containers that can use portions of the resources of that machine. And so, nowadays servers have hundreds of gigabytes of memory in them, and they don't necessarily always use that amount of memory all the time. But with containers, you have the ability to break it up and use that memory 100% of the time.
Right. And actually, we've got JJ to the 4884 in the chat room who he wants to have a conversation on open source Windows, which, the interesting thing is, I don't think that's nearly as important anymore, because I think even Microsoft has recognized that you can build applications, you can build these containers, and you don't really have to care about what platform it's running on. It will run on any hardware, it will run on any software, it will do its own thing. And in fact, if you look at the move that Microsoft made with .NET to contribute a large part of .NET to the Open Source Foundation, and also to create a free version of Windows 10, a stripped-down version of Windows 10 that will run on Internet of Things, it's kind of like going open source without really going open source.
Yeah, I mean, if you want to be a tinkerer and you want to play with the kernel and you want to change, you want to add services, you want to change the GUI. I mean, a lot of people wish they could customize the start menu. There are companies out there that do it, but they do operating system hooks to do it. They want to make it easier. I guess it makes sense you would want it open source, but Windows is an ecosystem, kind of like iOS, and it's making people feel it's a little bit more comfortable because Microsoft controls that ecosystem in a way that controls the security, and they're opening the door to a lot more things like these nano compartment containerized things for Windows Server. So I mean, they're making it easier for people to do things, and they're making it easier for people to virtualize. They're making it easier for you to build a service. So I think it's getting closer, but I'm not sure if it'll ever be open source.
Right. Well, Lou, I could talk about this forever. In fact, we did have a conversation about this on This Week in Enterprise Tech last week, but I want to save as much time in the show as possible for the rest of the C mini module, because you are going to be getting us into pointers, and I think people need as much time as they can get. But before we move on, let's go ahead and thank the sponsor for this episode of Coding 101, and it's got to be Lynda. Now, when you think of Lynda, what you should be thinking of is a repository of knowledge on the internet. It's not just programming skill. It's not just computer skill. Lynda is the place to go if you need to increase your job skills training, if you want to learn Excel, if you want to learn hobby arts like photography and videography. It's the place to go if you want to learn how to fly a quadcopter. Lynda.com really is a place to go to find out information about anything you want to find out about. And it's such high production values that it just helps you learn. You don't spend a lot of time thinking about how you would do the lesson. You just get the information that you need. Now, Lynda.com is for problem solvers. It's for the curious, for people who want to make things happen. Maybe you do want to learn that new programming language. Maybe you want to develop an app. Maybe you want to sharpen those photography skills. Or maybe you want to redesign your website. Lynda.com has everything you need to feed your curious mind. Some of the courses that I would recommend are Up and Running with Mathematica 10, Programming the Internet of Things with Android, and the Foundations of Programming, Code Efficiency. They also have an amazing series called Code Clinic. It's a 6-course series where Lynda.com experts look at common code challenges and offer their solutions using C++, C#, Java, PHP, Python, and Ruby. Now, I've been using Lynda.com for reference whenever we do Coding 101 modules, and also here in the Brick House, we use Lynda because we switched from Final Cut on the Mac to Adobe Premiere Pro on the PC. And sometimes our editors just need to get that little clue for what tool transfers over in what way. Well, with Lynda.com's transcripts, it means that you don't have to sit through entire lessons. You can search for your question and find the exact part of the video that deals with that solution. You can watch and learn from top experts who are passionate about teaching. You can stream thousands of video courses on demand, and you can learn on your own schedule. That's important. Learning at your own pace allows you to watch these courses from start to finish when you have time, when you can consume them, and that just means the information will stick. Again, you can browse those course transcripts. You can take notes as you go and refer to them later. You can download tutorials and watch them on the go, including access on your iOS and Android devices. You can create and save playlists of courses that you want to watch to customize your learning path or share with friends, colleagues, and team members. And guess what? Your Lynda.com membership gives you unlimited access to training on hundreds of topics, all for one flat rate. Whether you're looking to become an expert, you're passionate about a hobby, or you just want to learn something new, I want you to visit lynda.com/C101 and sign up for a free 10-day trial. That's right, free 10-day trial. So you're out of excuses. This is how you need to learn, and it's how you need to learn now. That's lynda.com/C101. And we thank Lynda for their support of Coding 101. All right, Lou, let's get to it. When we last left our intrepid explorers, they were just diving into C, and now you've got a little something for us. Where do we go?
Little something. So I think what the first thing I want to do is somebody asked in Google Plus the other day, can we use Visual Studio to program in C? And I wanted to show really fast just how to get Visual Studio to work with C. So if you had just the Windows desktop version of Visual Studio Express, I have the Ultimate Edition, but it doesn't matter. It's going to work the same exact way. All you do is create a new project, and in there you're going to choose Visual C++. It's a little confusing, but that's what the C compiler is kind of coded or blanketed under. And then you can just put whatever name you want here. So name, and then I'm going to just hit OK, and watch what happens. Really quick, we get this window that's going to pop up and say, let's create a little application using a wizard. So I'm going to go through the wizard, and all I'm going to do is click empty project, console application, empty project, uncheck that box, and then hit finish. That's all I'm going to do. Boom. And now I'm going to get what you'll see over here, my little solution explorer. Once that gets created, hopefully it gets created. There we go.
There we go.
And then what we're going to do then is we're just going to add a source file to it. And the source file that I'm going to add to it is I'm going to go to add new item, and I'm just going to add, I'm going to again click on C++ file, but instead of choosing that, I'm just going to call it console.c. And I'm going to hit add. And now what you'll see is now I have a console. I'm going to have a console application that I can run, that I can actually start coding in C code with no problem. And once I actually compile this, I can exactly.
That's what we're used to. That's what we saw last time.
That's right. So it's exactly the same, and it's just as easy as that. So this is the application we showed last week. Again, we talked about this, where it's, we're including a library. It lets me do standard I/O, and then I have a little tiny function at the top here that lets me click enter when I want to enter and move on. But what we wanted to go into today is talk a little bit about kind of the underpinnings. What's the advantage of using C, right? Why are we using C? And I guess we talked about last week, if you remember, we talked about that the C is really close to the metal, right? It's machine. It allows you to compile and code in a way where you feel really close to the metal, really close to the memory, really close to the machine. And so I think that's really the key to C. And so the first thing I like to show is a couple things. One is the size of method, or a function that you have in C, which what that does is allows you to show exactly the size of a variable that you have in your application. Like, for instance, how much memory it's taking up. We like to call memory as a currency for your application. Back in the C days, when people used to code a long time ago in C, it used to be that they didn't have much memory, and they needed to be very specific on how much memory they used. So if you see here, I have a quick, really simple application that shows me creating a variable. That's an integer, and we talked about that last week. There's different types of variable types. In this case, I'm choosing an integer, and I'm setting a value to it. So I'm initializing it. They call it initialization. And I could have done this on one line too, but I wanted to be very explicit here so everyone kind of understood what I'm doing. And then I did the print statements like I did before. But the difference is we saw the first line where I'm using just a print statement, and I'm passing the variable and saying, hey, this is what the value of it is. But then the second line, I have another one called another print statement that I'm using the size of. And what this is going to do is if we run this, it will actually show us the memory size of the variable. And this is a lot different than, so you notice it has 4 bytes. So this is a lot different than if you use a high-level language like Python and C#,
right? Because
you don't necessarily know exactly how much memory you're utilizing when you're creating things. Now, they try to help you and say, okay, if you do an integer in C#, it's most definitely going to be this many bytes. But again, then you have the overhead of the CLR, which is the runtime and everything else. But when you're doing C, you know for a fact that my integer value is always going to be 4 bytes. And no matter how many integers I have, it'll be 4 times that many integer values.
And there's going to be people who are looking at this, and they're going to say, wait a minute, why do I care? My computer's got so much memory. But you have to remember that one of the things that C is still used for today is a lot of embedded programming. If you are using any Arduino-based machines, if you're using Atmega-based chipsets, you're probably going to be programming in C for just this reason. Because as you go to the higher level languages, you've got so many layers of abstraction that you don't know exactly where your memory is going. With C, you always know exactly how much memory every variable type is going to use. You know how much memory every method's going to use, and therefore you can predict how the limited resources of your embedded devices are actually used.
Exactly right. And that's important because, people don't really think about it today because you have these massive desktops, laptops, even your cell phone have 4 gigs, 8 gigs of RAM sometimes. So it's like, why do I really care about memory? But like you said, I mean, when you have these little type of Internet of Thing devices, you have to be very specific. Some of them only have, like the Raspberry Pi, some of them only have a small amount of memory so you can load an application to it, maybe 12 kilobytes, 24 kilobytes, and you have to be very specific about how much memory you're using. So that's why C is a really good language for it.
All right, so we've got that down. One of the primary advantages of C is that it's incredibly predictable on how much memory it's going to use, which makes it a unique language among some of the higher abstraction languages that we may use today, including things like C# or Visual Basic.
Exactly. So one of the things that one of the other cool little syntax tricks that I like to do too is, we have this value, and we know that it's a type, it's a number, an integer, and we know what size of it is, but maybe we want to know where it's at. So like we were talking about, computer has memory, and memory has locations, and those locations are represented by numbers. And sometimes you want to know where that location is on the machine. So like, for instance, when this application spins up, it gets loaded into a specific portion of my memory on the PC. And then when I load up other things in that program, it also loads them in that portion of the memory. So like, for instance, if I wanted to know what the memory address of this value is, I use this little cool syntax here called a reference operator, they call it. But basically all it is doing is saying, hey, go and get me the location in memory of that value. So if I run this, all you're going to see is this fancy schmancy number here, but basically all that's saying is that's the memory location of that variable. So again, it's kind of cool because now you're getting to the underpinnings of what your operating system is doing when you're creating variables, when you're actually programming.
Right. And this okay, again, this is keeping with that theme of getting really, really close to the memory. You don't see this if you're programming in any other language because you only know it's the variable. This is the variable, and that's where I'm storing that value. But in reality, that variable needs to actually exist in some physical piece of memory. And that piece of physical memory has to have an address, because when I'm going to the hardware, I don't say, oh, give me the variable called A. I say, give me the variable, or give me the data that starts at address this, and goes on for 4 bytes.
Right. And so we'll get into it a little bit with something called pointer, where it's basically a memory location. But one of the things in modern languages today, it's like C#, is when you pass variables around in your application, it can be done by what they call by reference, meaning you're passing the same copy of that variable all around. And when you're changing it, like let's say in a method or a function, it's changing the original copy, that original location. But in C, when you pass a value around, if you don't use a special construct called a pointer or a memory location, you're actually copying the data around. So if I were to create a function that actually passed this value somewhere, let's say I call a function called show me, and I passed it the value here, and I did something with it in here. Then what I could do when I passed this value in here, when I called show me, it would actually pass a copy of it, not actually the original value. So if I were to like inside here, set the value to something else, when it came back out, it would be the original value because it was not actually changing anything.
Right.
So that's kind of the key here is with some of the modern languages today, it allows you to pass by reference much easier. But that's where we get to the concept of what we call a pointer. And so what a pointer is it's basically just a variable where you can store or hold a memory address. And the reason why you want to do it, again, is like I said, is you want to sometimes be able to pass around not just the value, but where the value is stored. So this way, you have a better understanding of you actually have the ability to change the original value, so you're not actually changing a copy of it. And that, again, that's all around size of your program. You want to be very close to the metal. You don't want to be making copies of stuff and doubling up how much memory you're using. So, and the way you actually create a pointer is you use what they call a dereferencing operator. It's just a fancy way of saying, if I wanted to create a pointer here called value2, that's all I had to do. And what I could do is actually store the value of my so I just give the memory location to my original value. And I'm actually storing the memory location now in my pointer. And I can start using this and passing it around just as if I was passing around a variable.
Okay, now let's back off just a bit, because this is typically where people who are brand new to programming, when they first time they hear about pointers, they're going to go, wait a minute, hold on, Lou. Why wouldn't I just use the variable name? I don't understand. Why are you trying to make me do this additional step of trying to figure out where the memory actually starts, what its address is? What would be the simplest way you can tell them why and when you need to use a pointer versus just the variable name?
So I think the simplest way is that, if you're just doing a simple application like this and it's just a couple lines, it doesn't make sense necessarily to use a pointer. But there are some instances, like for instance, if you were going to be using an array or building an array, and an array we talked about before is just a kind of like a table of things, like table of things that are of the same type. So like just a whole bunch of numbers in a table. And I can store those in a big table. But what I could do for pointers is I can actually grab a location in that array right away by just using its memory location. Another way is, like I said before, if you wanted to build a function in this application and you wanted to pass it a variable, but you didn't want to actually copy the variable to that function, you wanted to pass the original one that's in your app, you wanted to pass the instance of it around, you could use the pointer, and that allows you to reference the original value. So it's really dependent on your application, but simple apps are not going to really do it. But more complex, having functions and stuff, as you start to build bigger applications, you're going to start using pointers for sure.
Right. And actually, that's actually a really good explanation. That's what you do. As you start, just use variable names. But as you get more advanced and as you start going back between methods and functions, pointers are going to become important.
Exactly right. So I wanted to really fast show you an example of what an array looks like, so that we can kind of show you the example. So we did an array before. I think it was just a very simple one, but I wanted to show you an example of what that looked like. So this is an array of, whoops, type that right. This is an array of just numbers, integers. And basically that's how I'm initializing. There's multiple ways to initialize it. You can initialize it by doing it this way. You can initialize it by, putting that I'm going to have 5 values, and then I can loop through this array. I can use loops, and I can do that way, or I can actually initialize just one index of that to some value. So there's lots of different ways to initialize array, but this is basically the easiest way of doing it, is just to do that one line like I was showing you. And the array will hold a bunch of different types. You can do an integer. I can do it in a character array, meaning I can hold a character array. Normally in C code is kind of like a string, like we've done in other coding. So like this will hold the word code in it. So there's lots of different ways to initialize array. And arrays are very useful because it allows you to store a whole bunch of data and be able to loop through it and iterate through it and all that stuff.
Yeah. Lou, I'm going to pull you back from just a bit, because one of the things that we like about being on the Twit TV network is that we can get immediate feedback from our audience. And we've got a question from Web0048, a very simple question. And I think, often we forget that this is actually a question. And that is, well, what does it mean if your memory has an address of 144614641? How does that become something that stores a value? How is memory laid out?
So memory is laid out in a software system by what they call a stack and a heap. And your application gets a specific amount of stack memory when you boot it up for the first time. So it's it gets very complex, but it's all dependent on different operating systems, the bitness of your operating system. But you get a certain amount of memory, and that memory has a beginning location and an ending location. Mm-hmm. And so, and that stack is kind of right in front of you, in the forefront. You're kind of what they call RAM, I guess you could say, and also. There's what they call the heap, which is more of like if you're using C++, the heap stays around for much longer. So like, for instance, if I were to create a class and an object, I put something on the heap, it will store it in a block of memory called a heap, and that will stay around longer for the lifetime of that object. But the stack allows me to just kind of put things on the stack, and as I use them, I pop them off the top, and then they just disappear over time because they're just values. And so that's kind of how your memory is structured. Obviously, it's more complicated than that. But again, your application gets a beginning address and an ending address, and then as you put stuff in it, your memory gets kind of reorganized and organized in the operating system.
Right, exactly. All right, take us in. So we're in arrays now, and you're explaining to us how arrays are formed and exactly what the structure is. What's the next step?
So I think the next step is I wanted to give a really quick example here of like how you could use pointers, and then we'll go back to how we can use pointers with arrays. And so this will make a little bit more sense after we're done with this. So let me go show you an example of what a pointer is. So we had this original example of us using a value and then setting the value. But then I declared another value here called value2, and I made it a pointer. And so what I'm going to show you here is, so the original line was printing out the value, then I was printing out the size, and then I was printing out the actual memory location. But then I wanted to do something different down here. I wanted to grab the memory location using that reference character there, and I wanted to put it inside the pointer. And so basically I'm saying that the value of this guy is now the memory location of this original value is now put inside my pointer. Mm-hmm. And so now what I'm going to do is I'm going to print it out. But what you'll notice is when I don't use the actual little dereferencer here, you actually print out the memory location of it, not actually the value. But if I use the little dereferencer, what you'll see is when I print this out, so the first line is the value, the second line is the size, the third line I use that little %, which is basically the referencer, and then the third line is me just using the value, the pointer. And you notice now I got the actual, again, the memory location. But then finally the final line is I'm using the pointer-based variable, and it's basically printing me out the actual value again. So the key here is basically considering that value, that pointer, to be the value. And that's kind of a cool way of showing that, oh yeah, you can use the memory location, you can use the actual value, or you can actually dereference it using a pointer. And so that it makes it a little easier to kind of understand from that perspective.
Right. So this is giving us the value, this is giving us the address where it's actually located, and it's giving us the size of the location. Nice.
Right. So now I think the last thing that we want to do is we want to kind of give an example of how we can kind of use arrays to kind of point out, because arrays are different than pointers, but they are very close to, they're not the same thing, but they have a ton in common. They're very in common. For instance, an array sets aside a contiguous span of memory for one specific data type. But an element in the array can actually be just a small offset. So like, for instance, if I'm at memory location 1 and I put an integer in that array, then I can say that the offset of that value is actually 1 plus 4 bytes, because I'm basically moving over 4 bytes to get that value. So I'll show you an example of what that means. So this way it's a little bit more easier to understand. So for instance, in this example, I'm gonna get rid of this for loop so it's a little bit easier. So what we're understanding is I have a character array, 4 characters. And what I'm going to do here is I'm going to show you that what the address of that just the array itself. And what you'll see here is the address of this guy. Whoops. Oh yeah, I gotta actually initialize this thing first. Sorry about that.
It doesn't know what that is.
There you go. That's what happens when you compile and you write code and you don't compile it. Okay, there we go. So what I'm going to show you is that the first element of this array the 0 element of this array, because actually arrays start at 0, they don't start at 1.
Right.
Is this memory location. And the key here is, so if I were to increment that memory location and say I want the second one, what we'll see is it'll actually go up in 4 bytes. So I actually will let's print out 2 versions of this.
Yeah, give me the first one and the second one. So people can actually see that, no, really, an integer is 4 bytes.
That's right. Whoops. Would help if I did that.
There we go.
It's not compiling.
Yeah, wait.
That's all right.
What are we missing here?
Yeah.
NC.
There we go. So what we're seeing is that I'm actually moving up one element in the array, and it's giving me the address of that next element in the array. So you see it's actually 1 byte difference because I'm using it. I forgot this is not an integer array. Normally it's 4 bytes difference.
Right.
This is a character array. Characters are one byte by themselves. So basically I moved up to the second instance of that, to the second element, and now I moved up 1 byte. So if I were to add a third one or fourth one, all it would do is just move up one memory location 1 byte. And so that kind of shows you how they
just for giggles, go ahead and change the array to an array of integers, and there we go.
So if we're going to do this, and we do 5, right, and then we'll change this really fast,
or just comment it out.
Yeah.
Oh, even better. Yeah.
So there we go, and then we'll do 2 of these, right? So we'll do this, and then this, and then we'll show that guy. So what we can see here is, okay, the first one's a character array, right? We go up 1 byte as we go up each element in the array. And then the second one is an integer. As you can see, there's a memory location, and then it goes up 4 bytes.
Right. So this is memory usage in real time. This is exactly what's happening inside the machine. When you declare that array, it's actually going to take all that contiguous memory, and you have a starting address of the array and you have an ending address of the array, and every element will increment depending on how much space each of those elements will take.
That's right. So again, it's you're kind of close to the metal here. You're starting to understand using variables and just how much space they're taking up in your application, and then where they're located in your physical memory. And that's actually a huge step to really understanding how computers work, if you think about it. So once you start to understand that, and then doing embedding programming, you'll really start to understand why you need to pay attention to that type of stuff.
Right. Although there is something else here. I mean, arrays are great, and I actually spend a lot of my time working with arrays because, well, I do a lot of analysis of data. However, when we're dealing with arrays, we're dealing with an array of similar elements. You've got an array of characters. You've got an array of integers. You can have an array of doubles, whatever it's going to be. There is another data type that actually can combine disparate datas. Now, that's called a struct, right?
Correct. So a struct is basically a collection of variables that are kind of blanketed under a single name. And so, for instance, if I wanted to create, and so we talked about this before in some of the other programming languages where you can have, structs that are, you bring things together and you basically characterize them. And so I'll show you an example really fast of what that looks like. If you show my screen again, I'm gonna actually create a struct called person, and I'm gonna put it on. I'm going to I'll show you on the screen here. And what this person has is several attributes that describe it. So in this case, I have the first name, my middle name, my last name, or the student's last name, their height, their hair color. And this allows me to, again, like I said, collect a bunch of things and collect them under one single name. So for better handling. And in this case, it's just a collection of properties or attributes in this case. And so there's lots of ways to declare this. One, I put the struct and then the struct name, and then I put all this. There's multiple ways to do this, though. And I'm going to try to show you a couple ways so you kind of understand. So if I wanted to start using this, I would actually want to put this next line in here, which is telling me that I'm creating a new type of this struct called student person, and then I want to go and use it. But there's also another way to do it, which is even easier than this, and that is by using the type def right up here. So I can just do type def. And now I don't even need this line anymore. We've seen this kind of collection in higher level languages, and typically it would be a class. Right. Exactly. And structs are made to be value types, so they're very lean and mean. And again, you can pass them around using by using pointers, and allows you then pass the original value around. And we'll actually show an example of that, what that means, of why do I want to actually pass an instance of this around versus just a copy of it, right? Because it doesn't make sense necessarily to pass a copy. And so a good example is I'll show you real quick, is what we like to call pass by reference or pass by value. And so I'm going to create two little functions here that have pass by reference or pass by value. And the key here is the first one is not going to use a pointer. It's just going to say, okay, I got an instance of this thing, and I'm going to pass it, and I'm going to set the height. And then the second function is saying, okay, but I'm going to pass it, but instead this time I'm going to use a pointer, and I'm just going to pass the memory location of that, and then I'm going to go change the height of it. And again, I'm showing you two ways to actually access here. One is called this dot referencer, and or the member operator is called this little dot right here, and the other one's called the structure pointer operator, and that allows me to go and say, okay, I have a memory location. Let me go and get this member of that of the actual object that's at that memory location and set the value.
Right.
And so we'll show you let's show you exactly what happens now if I actually create an object of this. So down here in my application, I'm going to delete all this so we can actually see stuff. And I'm going to create what we call an instance of this person called person2, and I'm going to set their name to be Jane, Jill, James, and I'm going to give them their age of 19 and their height of 65. And this is basically, I'm creating an instance of the struct, and I'm initializing some of the variables on there. And again, this is very similar as we talked about in an array. I did the exact same thing for array, where I just used these little curly braces and I initialized it. And so now the first thing I want to do is I want to pass it by value. So let's see what happens. So what I'm doing here is I am passing the value, and I'm going to print out the height in inches after it's done. So I'm going to use the debugger. This way we can do one step at a time. So let's see what happens here. So the first thing that happens is I'm going to step into the application. I'm passing this by value. So what happens is I'm going to go set the value to height to inches. So what you'll see right now, the height in inches, it's really, really tiny on the screen. I apologize.
Yeah, actually says, Zach, can you zoom into that, Zach?
Yeah. But what the debugger is showing you is the value right now is 65, right? Because I told them that the height of this person is 65 inches. But what I'm going to do is I'm going to change it to 10. So once I'm done with this, now it says 10.
There we go.
So now I'm going to pop out of this function. I'm going to come back down to print, and what you'll see is what actually prints out is 65. And the reason is because I didn't actually pass the it disappeared. I didn't actually pass I didn't actually pass the actual instance of it, which is this guy right here. I passed a copy of it. So when I got inside this function, it changed the value to 10, and then when I popped out of that function, it went right back to 65 because I don't have the same copy of it.
Yeah. And that's actually a perfect example of when you would want to use it, because if you want these changes to actually affect the value that you're going to display later on, you can't just pass a copy. You better pass the reference.
Exactly right. And so that kind of segues into the second part. So the second part is, so now instead of passing it by value, now I'm going to pass it by reference, meaning now I'm going to go and grab the memory location of it, and I'm going to pass it by reference. So basically, I'm passing in a pointer, which is this guy, a memory location, and then I'm going to change it. So let's look what happens then. So I'm going to put a breakpoint right here that lets me stop. So that's the by reference, and again, we have this guy right here. And then, oops, I don't want two continues here. And then let's step into this guy. So now the value, again, if we look at this again, the current value is going to be still 65, right? Because we already passed by it. So again, it's really tiny down here, but it says height in inches, 65. And then we're going to step into this pass by reference. So if we step in, again, we're going to change. Again, we're using this little pointer operator, but then we're going to change it to height inches 10. But when we pop back out now and I print it to screen, what you're going to see is the student's height is 10.
That's exactly what we want.
That's right. So the key here is I wasn't actually passing or copying that data. I wasn't making an exact copy of it. I was, whatever the size of that instance of that struct is, or that type, I wasn't copying it over into another portion of the memory and then changing a value. And when I was popping it back out, I was, again, back to my original value. I was actually taking that original instance, getting the memory location of it, and saying, okay, I'm just going to pass this number to it. And then the application, the function, is going to know that I'm going to take that number and actually set a value at that memory location. And that's what it was doing. So when it popped back out, now I have a new value. Right. And so that's kind of the key. So when you're doing...
Let's flip it around a little bit, because now we know why you would want to pass by reference rather than just passing a copy. But when wouldn't you want to do that? When would you want to not give them the pointer because you'll be changing the original data?
That's a good question. So I think when you wouldn't want to do this is if you were like, for instance, you had a separate function that would go and do some operation, but then you wanted to kind of go back to the original value when you came back out. So like, for instance, if I had a laundry list of students and I needed to calculate something, like for instance, I needed to calculate what their bill is going to be. So I passed an instance of a student in, and then this application would go and get their, how much they owed, and it would calculate it and print it to screen, and then it would pop back out and loop through to the next student. And the key here is if I was passing by reference, it would actually change that student object over and over again to that value. So when you were actually printing, you would find out that, oh wait, since I'm passing it by reference, it's actually showing the student's name and address and what they owe for the same student over and over again. But if I actually passed by copy, I'm just copying the data in there, and then I'm doing something with it. And then when I pop back out, I can set a new value. And so that's kind of the key is it's all dependent on what your application's doing and when you actually want to pass the actual thing, or when you actually just want to do something separate over here and then come back and do something and do your own thing again, kind of thing.
Right. The example that was often given to me is if you were trying to create a program that does, say, conversions to multiple types of currency, you wouldn't want to be passing the reference every time you do a conversion, because then you're changing the original number and every subsequent conversion is going to be off. You would pass copies, and each function would do the conversion and have its unique value. So yeah, this is actually something that you can figure out when you're in the logic tree step of writing your program. Just, okay, do I need to preserve this function? Do I need to preserve this value, this data, or do I want it to be overwritten because the new value is what every other function is going to use?
Right, exactly. It's a little confusing, but as you start to use it, you'll kind of understand. Again, if you start to use the size of function, it's kind of cool because you'll start to see that, okay, the size of my student type is actually X. So let's say it's 12 bytes. And then when I actually pass it by value, you'll notice now you're copying that 12 bytes to another function and you're doing something else. And so when you're doing embedded programming especially, it's important because now you have 24 bytes worth of data that it's on your memory, it's in your stack of memory, and it's taking up that double the amount. But when you're passing it by reference, you're basically saying, you know what, I'm not going to copy. I'm not going to create a copy. I'm just going to pass the actual original version of it. And so now I really still only have 12 bytes of data. And so that's super important when you're working with little devices like that.
Right, yeah. And we're actually going to be doing more projects using Arduino and using embedded processors. So yeah, it's a good time to get into the proper way of handling your memory addressing. I mean, this is good programming. Be efficient with how you program, and then you never have to worry about using more resources than you think you're using.
Great. Yeah. So the very last thing before we kind of wrap up is I wanted to show how you can kind of set up similar. So I have a student person here, and I wanted to show you. Sorry for my naming convention. I have a whole bunch of other. I have a whole bunch of other types I wanted to create.
There's a lot of persons in there, Lou.
A lot of persons, student persons. But in this case, I'm going to create a person on it. But what you'll notice here, and instead of using arrays, I'm actually using pointers. And the key here is you can actually interchange them in this case. So when I initialize this, I can actually initialize this to a 100 element character array. And that's kind of the key. So if I were to go and initialize something like a person down here now, I can actually initialize this guy to a 100 character array. So if I wanted to call him Bill, now a character array is the same thing as a string in this case. And now person has, if I were to look at the person's first name, it would actually be Bill. And so that's kind of the key is the interchange. That's why I said arrays are very closely related to pointers because, again, they're just copies of the same type over and over again. So this is just 100 characters in a large array. But again, I can declare a struct that has an attribute called first name. And again, it's a pointer, but it will point to an array when I initialize it. So that's kind of the key is that they're almost interchangeable in a way.
Right, right. Nice. Okay. Well, Lou, what do we want to leave our code monkeys with? I mean, because this was a mini module. So this was just a 2-episode hit of C. Now, we will be coming back to C again and again because, it really is a nice foundational language. It's a nice place to ground yourself and learn some of the more important foundational pieces. But if we wanted to challenge them, what would you do? Because, again, we do have to give them the code. We have to give them the assets that they've seen in this episode. But what else would you want to tack on?
So get familiar. So like for me, I like to print stuff to the screen. So just get yourself familiar with code, right? So for instance, get yourself familiar with writing a console app, doing some variables, passing them by value like I showed, print them out, show the size of them, that kind of thing. So just really kind of understand what's happening when the application. And what you'll do is you actually find you'll type it wrong. Maybe you'll use the wrong, the dereferencer versus the referencer, and you'll find that at some point you'll get like the compiler or the runtime will say, "Oh, you have an access violation in memory," and it'll tell you why. And it's basically just trial and error. Just get yourself in there and get yourself used to using and programming. And we just went through very base concepts, but now as you get really into complex C coding, it just builds on top of those bases. And so I think take the code that we have, muck with it, and break it, and the compiler will help you, especially if you do Visual Studio. It will help you. It will give you very specific errors. And then just, try some other stuff, maybe put an array of people, and then maybe learn to actually go and use what they call loop and loop through that array. So just start building out the application and doing other things, and you'll feel more comfortable about it.
Fantastic. Lou Maresca, he is our code warrior and our super special guest co-host. Seriously. Okay, we're gonna do something about that, Lou. Could you please tell the folks where they can find you? Because of course you're going to be all over the Twit TV network. I have you as a guest very often on This Week in Enterprise Tech. I do believe we've got some reviews in the can for you for Before You Buy, so we're going to be seeing you there. And of course you are often, almost always now, on Coding 101. But where else can people go if they want to find out what you've been working on?
Absolutely. So you can always find me on Twitter, LouMM, LOUMM. And of course, all my daily work that I do at my day job is at crm.dynamics.com.
Yeah, and before we bid you farewell, I do want to say that the next time you see us, because this episode is actually going to be going up on Monday, the 4/13, whatever it is. But the day after we have the 10th year anniversary for the Twit TV, we're going to have Lou in studio, and I believe we're going to be recording a couple of episodes, and hopefully by then we might have some good news, Lou, you think?
Yeah, super excited.
Can talk about
stuff. Excited about the 10th anniversary too.
Yeah, right? That's perfect. Everything's perfect. So good news coming, and I think it's going to involve Lou MM. Lou Maresca, we salute you, sir, for being our code warrior, for being the constant presence of knowledge here for Coding 101.
Love being here. Thanks so much.
And folks, we want to thank you for sticking with us. We will be here every Monday. Well, except for this pre-recording and any of the pre-recordings we do in the future. You're going to find us at 2:30 p.m. Pacific time at live.twit.tv. And as long as you're going to join us live, why not jump into our chat room at irc.twit.tv? It's a place where you can ask questions. You can tell us whether or not you're getting the material that we're laying down. And this is very important. When you tell us that you're not understanding what we're talking about, it gives us a chance to back up and say, oh, yeah, we should probably explain that concept, that thing, that component. So jump in. That's right, live.twit.tv and irc.twit.tv. Don't forget that you can always go to our show page at twit.tv/code or Coding 101. It always goes to the same place. Here you'll find our entire back inventory of episodes. So if you want to download a previous module, if you want to look at what we did with C#, actually a couple of modules, or with PHP or with Perl, you're going to be able to get it right here. And you'll also find a place where you can subscribe so you get every episode automatically to your device of choice. It's one of the things that we do because, well, we love you. Don't forget that we've got a very active Google Plus group. Just go to Google Plus and look for Coding 101. It's a great place to go if you have knowledge that you want to give or if you have questions that you want to ask. But don't worry about it if you can't find that, because you can also find me on Twitter. Just go to twitter.com/PadreSJ. That's at PadreSJ. And you'll be able to ask me questions about the episodes, about the guest, and suggest future languages that you want to learn and future concepts that you want us to talk about. Don't forget, that's twitter.com/PadreSJ. Or in this case, you can find out what happens when people on Wednesday try to wake me up. That's right. Just go back to bed. The next time we see you will be on 420. Until then, I'm Father Robert Ballecer. This is Coding 101. End of line.